Sure. All right, there we go. So, right now, while we are at the beginning, okay, um, if this is your first time into programming, I want you guys to download Anaconda. All right, so here is the address at the top. I'm just gonna give this to you in the chat as well, just to over communicate. Right. Where are the others? Hmm. Okay, let's just hope they come back. And so I'll just be giving this instruction for the recording for the others. Um, just go to anaconda.com and then yeah, let's just start at the beginning. Anaconda.com, you can click on this bar here at the top and then go to free download, right? After free download, you can just go down and then look for skip registration. All right. After skipping the registration, you can just click on download here. If you press this button, it will automatically detect your operating system for you so that you don't have to decide. And usually it's this one really, but you know, just use the automatic one and you should be good to go. So when you install it, it's fairly straightforward. Just keep on clicking next. And then if there's something that they want you to enable or authorize, just click yes. Anaconda is relatively safe, so there's nothing to be afraid of when you allow them something in your computer. All right. Um, so that's it for Anaconda. Um, yeah. So what are you using, guys? The one from AFP. What do you usually use? Your IDs. Um, was it Sir Sir June,
Usually we use Visual Studio encoding, sir.
Visual Studio? All right. Yeah, that's okay. Visual Studio. So you're gonna need a plugin for that one if you're gonna want to view the file that I am using here in the discussion because I'm using Jupyter Notebook. All right. So in order for you to open this one in Visual Studio, from what I know, you're gonna have to download a sort of plugin for this in order for it to load properly. All right. So just a bit of heads up. And let's see what else. LMS. Okay. All right. Let's see. There was a notification about this one. LMS. Mm, mm. All right. So I did not receive any notification, but what you're looking at right now is the LMS for our school. All right. So our learning management system. And if your accounts was emailed to you, then you can log into this website, right? So just log in your credentials, and then currently it's in mobile view, or no, not really a mobile view, but a lesser window size. Let's see. Where is my courses? There we go. So if you click on My Courses, you will see all the courses that you have enrolled and graduated from. So in your cases, you're only going to be seeing one, and that will be Data Science Bootcamp. All right. And when you click on that button, this is what you will see. Okay. Basically, it's just a rough draft, or not really a draft, more like what we will cover for the next 11 weeks. All right. And this is also where I will be uploading. my files. Okay. For the recordings, it's gonna be uploaded on YouTube, so you can just watch it there. It's a private link, so only those with the links can watch it. All right. So let's see. General. All right. So as you can see here, I have lecture notes for other batches. So I'm gonna make another one here, lecture notes for your batch. Okay. So basically the one that I will be typing on here is what you will get also. Okay. And then mm, okay, for the PowerPoints, if you click on one of the topics like this one here, this is the one that we'll discuss today. Um, there will be, yeah, this one. So if you click on this button, you can download the PowerPoint that I am using if you want to review it. All right. And that's basically it. All right. Okay. What else?
Sir, excuse.
Yes.
What I'm seeing on my dashboard is only general and then the rest are new section. I cannot see these options like the intro, control, structures, and other functions.
Mm.
S-
Does it say data science bootcamp, sir?
Yes, sir.
Okay. All right. Let me see. Data science bootcamp batch 16. Ah, okay. So they made a new one. All right. Okay. All right. So they want to separate different batches. Okay. All right. I got it. So I wasn't informed of this. Roblox design. All right. So I wasn't really informed of this, that they will be doing it like this. Separating it into different uh courses. So this is your new batch. All right. So I guess I'll have to upload it here, the PowerPoints again, and then you can use that one as well. All right. Okay. So thank you for letting me know, sir. Let me just put this one on the side so that we can remember. What else? If you guys haven't answered the pre-course survey, post-course survey. No, 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 pre. All right. So this is the pre-course survey. If you haven't answered this one, kindly answer it later if you have time. Um, so I'm just gonna share to you the link as well on the chat box for everyone to see. Pre-course survey. All right. And let's see. For the submissions of projects, usually I just have it by email. I let the students send it to me via email, their codes, usually in just text format and notepad. That usually is enough. All right. So I think that's all there is. Um, yeah, I think we can begin our lesson now. All right. So, the first 5 sessions here is mainly focused on um how to use Python. All right. So from basics to advanced, but not to the very advanced part, right? More like just enough so that you can play around with different libraries, right? You can understand how to read them, um, their syntax, all right, and how they work. Okay. So if you guys are already used to Python, okay, it's completely all right if you skip a few classes, that's fine. But usually my students in this boot camps are fairly new, so they tend to go through with the beginning. All right? Okay. So laser pointer. All right. So there's gonna be a lot of parts that we're gonna skip here. Basically, it's more on introduction. Okay. So computer science focuses more on algorithms and information processing. So algorithm, as we all know, is just like a recipe, right? So this is essential in data science. Um, if let's say you are trying to make a sandwich, right? Um, you're going to be given instructions to start with a bread, right? Followed by cheese and then lettuce and then whatever it is that you want to put in between, right? And then all the others as well, okay? Put on top. So that's basically the algorithm. And the main point here is that it is reproducible by anyone if they just follow the instructions, okay? Especially if it's a computer, right? They will always have the same result, and that's the beauty of it, right? Um, but as humans, we can't actually get a perfect output each and every time, right? Except for a computer. All right. Information processing from the word itself refers to manipulations and transformations of data or let's see here. Okay, sorry, there are some notifications. All right. Um, where were we? Hmm. Right. Information processing. So manipulation and processing of data so that you can get useful outputs, meaningful outputs, right? So this is what we did earlier. The example, computing agent, if you see this term, it usually means it's the human being, but it can also mean that it's a computer program because, just like a computer program, mm, both programs and us as humans follow instructions. So that's why it's a computing agent. Um, Sequence of steps, yeah, it's just a repetition. Let's see. Features of an algorithm consists of a finite number of instructions, yes. Although there we can put some conditions there in between, like that can alter the output. We can do that one. Each instruction is well defined, yes. It has to be clearly understood by the computer. So that's why we have to give it correct instructions. The scribe process that eventually halts, yes, it should stop at some point. All right. If it will not stop, then there should be a condition where it can exit or something, and then solves a general class of problems. So there are cases where an algorithm that works on one thing can also work on different things as well. So that's what it's trying to say here. Computers can be designed to run a small set of errands, performing specialized tasks. Yeah. Okay. Again, these are just basic IT terms, computer science terms. Information processing. All right. So information is also commonly referred to as data. So whenever we are trying, uh, let's see, when we are trying to process data, it always starts with the input, as it says here. Then it transforms information according to well-defined rules and then produces the output. But we can put some things in between here, like the processing part, where the data is analyzed, can organize data, right? And then we can transform it into different data types that we want. Okay, so they can be strings, numbers. We'll get into that more later on what those things are. Um, the algorithms that describe the description information process can also be represented as information. Yeah. So just like what it says. Okay. So these are just examples on what things that we usually see can be represented as data. So we have images, music, human speech, and video. Actually, there's a lot more. Okay, we have text data, we have numbers like numeric data. All right, there's a lot of numbers, stocks, weather. So there's a lot. Images, of course, we have audio. It's not here. It's more generalized into music, but audio, yeah, we can process audio. We have what other data? We have sensor data like LiDAR or sonar, if you're familiar. So sonar is usually the one that we hear, right? The sonar is for submarines, but these days LiDAR is used together with sonar to produce a more detailed 3D view of an environment. So LiDAR is short for light imaging detection something, but it's basically using light, right, to gauge the distance between a certain point to another point. So you can get the height of something. Okay, so this is usually used in um when let's say in Google, right? Google uses this one. They pass over some kind of drone on a certain area and then they scan it, right? And then upload it to Google Maps or something. And then you can get the heights of all the houses that it passes, the mountains, those kinds of stuff. So that data is actually available. I don't know if it's for sale or for free, but that data is available. All right. So there are a bunch more data out there, other than the one that I just said, and some of them remains to be discovered still. Okay. Uh, the structure of a modern computer system, I think we can all skip this one, right? We have hardware, software. Software are the programs that we use. Hardware is basically the stuff that we interact with, okay, to talk with the computer, right? So basics of computer hardware, we have memory, CPU, and a set of input-output devices. So our input-output devices are the mouse, the keyboard, those kind of things. Output are the speakers, monitors, all right? Computers are also works through various ports and connections and connected to networks to other devices, all right? So just a quick description of these things. So ports are like what I always tell my students when I describe ports is that you can treat them as doors. You can treat them as doors, um, as an analogy, right? But in terms of what they are doing in your computer, they are the services or the applications that you are using. Okay. So we call them ports. Um, and they allow sending and receiving data from those applications, right? From those services. Okay. So more like a virtual endpoint. That's what a port is. Okay. A network, right, is more like a highway, a digital highway that connects a lot of computers. Okay. Not just computers, all kinds of devices, right? As long as you can connect to it, you can access it. All right. So, um, a bigger example of this is that if you were to think about ports and networks, right, you can relate to them how our postal system works, right? So our postal system, right, um, when we send letters, it's usually delivered to mailboxes, right? So those mailboxes have a unique number, right? And then they serve as the specific endpoint for sending and receiving emails, all right? Um, so the city itself, right, in that case is the network, right? It has all the roads that you need to go to each and every service there is. Okay, so you can imagine it that way when you're trying to think of ports and networks. Um, RAM, we call this internal or primary memory. processor is the central processing unit, or basically the brain of our device. Okay, in all of our devices, really, no matter how small it is. And then, so these are our hard drives, external or secondary memory. We have magnetic, semiconductor, or optical. So if you are familiar with these things, magnetic and optical, it just shows your age, right? If you're familiar with those things. So optical, these are the CDs, DVDs, Blu-rays, in the past. These days we have the cloud, we have USB flash drives, we have external hard drives, we have solid state devices. Okay, the latest one is the M.2, if you're familiar. So that's the latest one. Um, we also have tape drives, if you're familiar. So it's usually used for archiving purposes. So that's what it is. Um, so this is a basic view of what it looks like inside of a computer memory, right? So each cell, right, stores these numbers, okay, numbers, ones and zeros, okay? And basically what the computer does is just read those numbers, okay, and then transform them, okay, into something else when we are trying to use those data. Okay. Let's say, for example, the sets of data is actually for a specific part of the video. Okay. Describing the pixel data for that part of the video. Let's say this is red, green, red, green, or a combination of red and green, right? Because that's what pixels are. Okay. Each pixel has three colors depending on what kind you're using. So it's either red, green, and blue, or same YK. Wait, RGB, and then okay, but there's other sets of colors other than red, green, and blue that you can use to produce all the colors in that is possible, right? And depending on the electrical signals, okay, it can determine how much voltage they should send to that specific LED, right? Just enough to light up at that specific color, okay, and then it lights up another LED at that specific color, and then their combination will become a new color. So, for example, the combination for what's that? Blue and green, it becomes yellow. I forgot, but there's, those kind of combinations. So from the basics, right, the primary colors, you can get all the other colors just from their combinations alone. So yeah, using that kind of concept, each pixel only has three colors. Uh, the minimum, that's the minimum. And the basic is the RGB one, or the red, green, and blue. All right. Computer software. Stored in computer memory must be represented in binary digits or machine code. So whenever we are talking to the computer, it will always be in machine code. All right. Now, you might be asking, can you code in machine code? Yes, we have tried that one before. It's really, really hard. It's very prone to error, and it's not really advisable. So what the great thinkers of the 90s did is they made some kind of intermediary between machine code and us, right? The people, right? So what they made was a language that can be used, learned by us, so that the computer can understand what we are trying to say, and vice versa, right? And hence the term programming language. Okay. We are just trying to speak with the computer or any device technically. Um, so these other things are not needed anymore. Mm, okay, so we're at the point where we reach the high level programming language. So high level programming languages, they are designed to be more human friendly. Okay, so we'll just skip all the other generations. Odds are only a few people are using those things right now, but it's still there. Okay, because there are some legacy applications left, right? It's still in the system. Okay. So it's more human friendly. That's Python. It's the most human friendly programming language there is. And it can work into different architectures. So when you say different architectures, it can work in Android, Windows, iOS, those kind of stuff. Okay. So basically it can work anywhere. So that's why it's a high level programming language. Okay. So our technology has developed to the point where it doesn't matter anymore where we code. It will work on any device as long as it accepts that code. Okay. Let's see here. So this is the basic flow of our program. So from the text editor, it will pass through the translator. If there are syntax errors, okay, it will output it to whatever output device there is. Other than that, if there are no error messages, it will pass it to the runtime system where at this point it can accept user inputs, right? It can display outputs and also some other error messages as well. Okay, so runtime here is let's see. If I were to describe runtime, mm, it's more like from the next of runtime, something is running and then you just have to run something else along with it, parallel to it. So kind of like your, let's see, an analogy of this is like you're riding a train and then you're also walking on the train or something like that. So um, you're running a process together with other processes, something like that. Again, we don't really need to deal with that stuff as data scientists. This is more like a general overview on what is needed in order to get into IT. A brief history, yeah, we can skip this one. Maybe we can focus on the important stuff like this one, Blaze, Pascal. So this is let's see. Hold on, guys. All right, sorry for the delay. So, something like this. They were turning points in history. So we have the abacus, um, technically regarded as the first computer, right? And then we have this Pascaline. We call this one the Pascaline. Basically, this is a calculator, all right? So it's using those wheels that you see there, right, to get some basic results that can be produced from mathematics, right? So it had limited operations like addition and subtraction only. Limited range. So from what you can see here, there's about three, six, 8 digits at most, right? Um, what else? So at the time, from my research here, this was fairly expensive, and you need to have kind of like a college degree in today's terms in order to use this one. And then, so basically, it's not really practical yet for common people to use it, right? But right now, these days, we have a calculator almost anywhere, even on our phones, right? So, there are technologies now that are in the same state as this one, where only specialized individuals can use it or access has access to it, right? One of those things is quantum computers, right? Microsoft just released its latest processor, the Majora 1. So it's the first quantum something available in the market. Okay, it's using quantum computing for it. So I'm not really sure yet what it can do, but they say that it can process a whole lot more than the fastest processor that we have today. All right. Um, so that's it for history. Yeah, we can just skip these things. Okay, this is actually important. So late 1950s, okay, the vacuum tube gave way to the transistor. So the transistor is a solid state device, okay? Now, what was the use for the vacuum tube? The vacuum tube is kind of like a holder, right? You have you have a certain value, right? And then um you want you want something to hold that value temporarily, okay? Like a variable. Okay. So this is the hardware equivalent of that. It's the vacuum tube. So it stores data, okay, by storing charges. So for example, um you have the number five, right? You have the number five, for example. And if that is in terms of ones and zeros, that will be 1001. 124. No, wait, 101. Yeah, 101. 124. So that's five. 101. And if it was translated into a vacuum tube, it will be um one is turned on, turned off, and then turned on. That was the vacuum tube, all right? The thing is, it was very expensive to reproduce, right? The vacuum tube is very fragile and it consumes a large amount of space in your area. So it wasn't really that recommended. But at the time, they didn't have any other option. Okay. But when the transistor was discovered, okay, this is basically just a switch, right? But depending on the state of the switch, it can either be one or zero. So this is the part where uh, you know, it's like magic because from the vacuum tube, right, from the big glass tubes from before, it became as small as a grain of rice, even smaller these days, okay? Inside of our processors, right? There are millions and millions of transistors there, one and zeros, that are working together to process our data. Okay, that's why it gets so hot. That's why it needs those heat sinks. That's why it needs those high, what do you call those fans? High rotation. I don't know what it's called, but the fans that spins a lot faster compared to other fans for CPUs, right? For GPUs as well. Um, some PCs nowadays go for the liquid cooling part, so they pass um, some type of liquid on the tubes to get the heat a lot more faster from the CPU, right? And that's always great. Okay, those kinds of advancements. Okay, other than that, IC is just basically the result. So IC is integrated circuit. This is just basically the result of the transistor. Okay, we can make smaller computers because of the transistor. So this is a big turning point, the discovery of the transistor. Next is ARPANET. Yeah, this is the basic part form of the internet before. Um, CERN, yeah, created the HTTP or the Hypertext Transfer Protocol. Um, what this means is that it's just basically a set of rules that we have to follow, right? So that different computers can understand each other, right? Over a certain media, in this case, over the internet. Okay. So if you just send information directly, no one's going to understand your data if you don't follow certain rules when sending it. Okay. All right. So from then on, we've created web applications, client server applications, right? Emails and bulletins. Okay. So I don't know if you guys have used the early versions of the browser. Okay. Have you guys used before the Netscape Navigator? So that's the oldest one that I know. Netscape. Um, what else? Yeah, I think that's the oldest one that I used before. Even at that time, it wasn't used a lot. So yeah, we have PDAs that evolved into PDAs. Steve Jobs created Apple, right? Social networking applications. So the first one that I used was Friendster. This was around 2002. But if I remember correctly, there was one before this. It was called 6 Degrees. So this was during 1997. Um, LinkedIn was found 2003. MySpace is 2003 as well. 2004 was Facebook, and then so on and so forth. Okay, for all the other social medias out there. Actually, we have too much social media nowadays that is not good anymore. All right, and then we arrive to Python. Okay, and this was invented by Gerda van Rossum. And this is a general purpose programming language for solving problems on modern computer systems. So there's a lot of things that you can do with Python. Actually, almost anything really. You can create games using Python. You can make websites using Python. You can create apps that work on any device using Python. And it's very easy as well. But these days, Python is more known for its data processing libraries and frameworks. Okay, so that's basically used for data science and data analytics. All right. So before, when I was in um, the BPO company, I worked as a reports analyst. That was my position, and I basically um, take the data for all of the agents that is working on a specific site, and then do some data processing using those things, right? Their call times, their HTs, those kind of things, and then generate a report that can um, help us evaluate their performance or something, and kind of like we can give some kind of projection as to what the possible um, result will be week after week, month on month, right? Year on year. So those kinds of projections, right? It's not really the advanced parts of data analytics. So at that time we were using Power BI to present our data. So yeah. All right. So let's see. Shell. All right. So the things that you see in this PowerPoint is being run in a shell. All right. So when I say shell, you can think of a corn for this one. A corn, no, not corn cob. The small part of the corn. So there's the kernel and then there's the shell, right? The kernel is the one that's in the middle, and then the shell is, of course, the protective shell. Okay. So basically, if you want to talk to the kernel, you're gonna have to go through the shell, right? Um, so the shell basically is your middleman when you're trying to talk to your device using text, right? Something like that. Um, Shells, let's see. Before, you can only see shells when you are at a terminal. So a terminal is a specific computer device that is connected to the kernel, but all you can see on your terminal is the shell, right? That's why it's called a terminal. Um, yeah. All right. So we are at the part where we will start with our first program. All right. So before we start, let's have a quick break, about 10 minutes, and then let's get back here. Okay. You don't need to leave. Just stay in the Zoom call, and then let's just get back here in 10 minutes. All right. So it's 2:08 at my clock. Please be back here by 2:18. All right. So 10 minutes, and let's begin. All right. So I'll just turn off my cam here. I didn't turn on my mic. Hello guys, are you here? Give me a thumbs up if you can hear me.
Yes, sir, we can hear you.
All right. So let's continue. Okay. So first things first, how to open our Jupyter notebook. All right. So I'm gonna switch screens into Anaconda Navigator. Okay. So this is what it looks like when you open Anaconda Navigator, when you finish installing it, right? As you can see, if you just go to home, there are a lot of different apps inside of it, but we're just going to be using one, okay? Specifically this one, Jupyter Notebook, right? Um, yeah. So just look for Jupyter Notebook and then click on Launch, right? And then you have to highlight the browser that you want to use, right? If you're using a lot of different windows for it, you click on the one that you want Jupyter Notebook to appear in. Okay, so I'm gonna click on launch and then click on my browser window just to be sure that I want it to appear there. So let's just give it a moment. All right, so it's here. Let me switch back. All right. So this is what it looks like. Jupyter Notebook for Chrome, if you're using Chrome. So from what I know, if you're using other browsers, it's gonna look a bit different. Okay. Um, Jupyter Notebook has access to your file system. So as you can see, it can see my desktop, right? So I'm gonna go to desktop, PCC, and then um, data science, right? So I'm gonna create a new batch here. So just click on new folder. I'm gonna create batch 16, right? And then inside here is where I will create our Jupyter Notebook file, right? So click on new and then uh, environment based. This is new. Hmm. Maybe it's this one. Okay, let's just try this one out. Python, Conda, environment based. Ah, yes. Okay. So as you can see, it has the extension IPYNB. So that's short for Python Notebook, right? Currently it's untitled, but we'll change that one. So when you create a new notebook, right, it will appear here as another tab. And then let's see. Mhm. So it seems that we cannot rename it here. Maybe we can rename it here. All right. So you need to click and then rename. There you go. I'll name it lecture notes. Okay. So I think I have to open it again. Leave. Okay. Select kernel. Hmm. All right. So in this case, just choose the one from Anaconda, the kernel from Anaconda. No need to change into different things. And then select. All right. So this is what I like about Anaconda because usually when you install programs, right, in your device, it also installs together sometimes the programming language that comes along with it. So if you have your device for quite a while now, odds are you'll have different versions of the same program. Like for example, Python, you have versions 3, 2, and 1, for example, right? Um, then what happens is that um, there will come a time where Windows will be using an older version of the program, and then you start using a newer one, right? That you installed before. So right now it's not referring anymore to the correct um, program to use. Okay. What happens is that it will create an error. So what makes Anaconda great is because it isolates itself from Windows, okay, into its own thing. It has its own thing. So it will not be affected by the different installations done by other apps that you put in your device. Okay, so that's one advantage. Let's learn this one a little bit. How to use the Jupyter Notebook. So it looks kind of new even for me. They've had a new update. So, uh, the indication is still here. It says that the kernel status is idle. That means the kernel currently is not doing anything, so it can accept new processes. If you are running the program, this will turn black. Okay, that means it's running something. And then the moment it becomes white, that means it's done. Okay, usually this will just go black and then go white directly with our examples here that we'll do later. But when you reach the part where you're actually processing data, depending on the data that you have, it's gonna go black for quite a while. So this is the difference between um, Jupyter Notebook and Visual Studio because you have no visual confirmation that it is still running, right? In Visual Studio, you can actually um, create print straight statements that you can see that will pop up in your output, just so that you know that it's still running. Okay, something like that. In Jupyter Notebook, it's not the case. It's more like um, Jupyter Notebook is more on presentation, kind of, because you can put notes as well in Markdown that you can edit. Okay, so Markdown is just uh, text formatting. For example, this is a heading, right? As you can see. So if you have different headings here, like heading, heading. So this is just a short example of it. So as you can see, the number of pound symbol that you put at the beginning is also the level of your heading. Okay, and if you run the program, which is just the play here, this is a cell, right? This is one cell in Jupyter Notebook. Okay, if you play, then it will run only that cell. As you can see, this cell is not being run. Um, so you have to set this one to Markdown. Okay, you can search this one. It's fairly easy. It's not really a programming language. It's more like you're trying to format text using specific characters. Okay, so instead of right-clicking and then clicking on bold or italic, right, you can just put some special characters in the beginning to format that specific text. So that's what Markdown is. And with this kind of setup, you can kind of like make a note and then at the same time some code below. And also it can output some graphs, right? For from data analytics. So it's all in one. Okay. If you have the file, you can basically use this one for presentation purposes. Okay. Next is we have code. So this is usually where we will work on. This is where we'll put Python code. Okay. Next is, let's see, let's go to view, show line numbers. All right. So I want you guys to click on show line numbers so that we can see what line number you are at. And then I can correctly guide you in when we are troubleshooting our code. Like, for example, go to line 10. and then change this line, something like that. So we have the usual buttons here, the play to run the program, stop to stop the program, of course. You can, right, you can put your mouse here and it will say click to add cell. Or you can just use shortcuts. There are some shortcuts here like um it's B, right, to create a new cell below. If you press A, it will create a new cell above the current one. If you press D twice, it will delete a cell, right? Of course, you can just click on it manually, like or right click, okay, and then delete. You can do that one as well. Let's see. Okay. Mhm. So there's a lot of new features here that I haven't actually, I haven't explored this one yet. They had a new update. All right. So let's get back to our lesson. Let's see. Okay, so we are at the first part of our um, Python training, right? And we are greeted by one of the simplest functions in Python, and that is the print function. Okay. So there's a couple of things that we need to discuss. So we need to discuss syntax, right? So syntax is basically grammar. Um, that is equivalent in English language. So in the English language, we speak with using certain rules, right? Grammar rules like um, subject verb agreement, all those kind of things, nouns, verbs, pronouns, phrases, those kinds of stuff. Where to put the commas, okay? So the grammar basically, how to put up the entire sentence to make up one complete thought. Um, the same thing goes with programming a language, but we just use a different name for it. We call it syntax, okay? And instead of all those rules in English, it's transformed into like arguments, parameters, inputs, outputs, those kind of stuff. So we're gonna be discussing this one here. Okay, so that's what syntax is. What is a function? So a function looks like this one. This is the syntax of the function. If you want to use a function, this is what it should look like. It starts with the name, followed by open and close parentheses. And inside of the open and close parentheses is an expression. All right. There can be more than one, or they can only be one, depending on your function. Now, what is a function, basically? So, a function is more like a pack of code, right? It's a pack of code that does a specific task or a set of specific tasks, depending on what it is, and it performs the same job perfectly each and every time that you use it. Okay. What is this used for? Basically, it's for reducing the amount of code that we have, so it makes it modular. Um, so we don't have to repeat a lot of code, right? Like for example, um, if you were to give someone an instruction like, "Hey, I want you to assemble." No, no, I want you to put in order these things. So put a bread and then followed by tomato, ketchup, and then um, beef, and then cheese, and then pickles, lettuce, and then another bread in order to make a hamburger. So instead of always repeating those things, those instructions, right? You can just save those instructions into one pack, right? And then you call that one a cheeseburger, for example. So all you have to do now is to tell your guy that, hey, can you make a cheeseburger? Right? So that's what the function is for, okay? Uh all your instructions is stored into one packed into one single instruction. So this is what is stored here, print. Okay. Now, do we know what's inside this function? What are the individual instructions inside of it? No, but there's a way we can see it. But right now, it's not really relevant, right? What is important here is we can use packs like this, okay? We can use functions to get a certain output, all right? Um, okay. So although it says expression here, technically what goes inside the open and close parentheses, we call those arguments. Okay, so arguments are anything that you um pass to the function. Okay, so what do you mean by pass to the function? Let's go back to the cheeseburger, right? What if I were to change something? Like, what if I want to, instead of beef, it would be pork, or instead of pork, it would be chicken. So you are changing the inputs, right, in order to have a different output. So you'll have a cheeseburger made of beef, a cheeseburger made of chicken or pork, right? So based on what you pass on the instruction, right, on the function, right? So I want a cheeseburger from a chicken cheeseburger, something like that. So you're adding an argument, okay? So that is what you put here in the side that can change the output, okay? Not technically change, but it can produce a different output, okay? Um, but it's more on the actual data itself that you're trying to pass. So yeah, that's it. Um, So let's have a try on this example. Okay, let's try it out. So again, you start with print, open and close parentheses, and then you follow it with a string. Okay, let's say, for example, mug, because I have a mug here, and then I'm going to run the code. Okay, so this is what the print function will do. Okay, it will, of course, show on your output section whatever it is inside here. Okay, depending on what it is. Okay. Now, currently, what we have inside is something called a string. You can identify a string based on those two quotation marks at the end and at the beginning. Okay. So whenever you see that one, okay, it's called a string. Right. Now, what is a string? Before we can identify what a string is, we have to identify first the smallest possible value, which is a character. Okay. Now, when I say character, what usually comes to your mind? So those are all the different um, things that you can type on your keyboard, right? You have the letters, the numbers, the special characters, right? So each one here is a character, the U, the G, the M. Okay. Even the space is a character. Okay. That is the smallest value that you can have, a character. Now, if you put all of those characters together to make a thought, or not necessarily to make a thought, more like if you put more than two, more than or equal to two of those characters, right? What you will get now is a string of characters. That's why you call this one a string. That's what the name came from. That's where the name came from. So yeah, so whenever you see open and close quotes, whatever is inside or in between them is a string. Okay. Now, strings are basically used for just representing the characters as is. Okay. They have no um meaning to the computer other than the specific sequence of characters that you want. Okay. Unlike numbers, okay, like for example, if you have another print statement here, like print, okay. So again, a print will just the basic description of print is that it will print whatever is the argument inside of the parentheses. Okay. So if you put a number here and then run program, you will output a number. Okay. But in this case, this is actually a number and it means something to the computer. The computer can understand what this number is. It can do something with it. Like if you were to use mathematical operations on it, it can understand what 45 is. If we were to use the same example here, but 45, 45, right? And then print. But this time we're going to be using a string. Okay, 45. Okay. So in this case, even though they have the same output, all right? They have the same output because that's what print does. It will create an output based on what you're giving it. Okay, so the output will always be in the same format. Okay, but the 45 here is different from this 45. Okay, the 45 here is a number, right? This one is a string, right? It's just looking at the combination of the character 4 followed by the character 5. It There's no numerical meaning to it, unlike 45 here. Okay. Now, if I were to show you a quick example of this, it will be something like this. Okay. By the way, those things are called data types. Okay, so we have different data, okay, that we presented. Okay, we have data that is in number and we have data that is in string. Okay, so number and string are the types of data that we have, the basic types of data that we have. So they are called data types, right? Okay, so if I were to, let's say, print here and then 45 plus 45. Okay, you can actually do something like this, right? um Python can understand when you are using operations inside of parentheses. Okay, this is what makes Python very user friendly. I mean, other programming languages can do this one as well, but um for my experience is a lot easier in Python. Right, so always remember when the program runs, it always starts from the inside out and then from top to bottom. Okay, that's how the program is always run. Um, so if we start from inside out, all right, so it's gonna add the two numbers first. So what will be the result? It will be 90, right? So we can just imagine this one becoming 90. Right? 90, right? And then since that is already the lowest it can get, right? There's no more other operations inside, then it can proceed to doing its actual job, the print. Okay, and then if you press enter, it will come out 90. So we don't actually need to make it 90. You just need to I was just showing that one to you. Okay. So take a look. It has the same result, right? Because in the computer's memory, it processes that one and then tells print that the value here that you see is actually equal to 90, and then it prints that value. Okay, but if we were using two different data types, like a number and a string, for example, all right, so now we have two different data types. Okay, and if I were to run this, all right, it will produce an error. So as you can see here, unsupported operand type for the plus operator. It's describing to you what it sees. Okay, it sees the first part as an integer. This is an integer data type. It's short for a number, right? Integers are what? They are the whole numbers in mathematics, right? And then the second one is a string. Okay, So it can correctly identify that one. Unsupported operand type. Because what it's expecting is because the first part is a number, it's expecting that the second part is also a number. Okay. The same thing goes if you were to reverse this one, but the error will be different. So Python now will expect something else. Okay. It will say, what's happening? What is happening with my, uh-huh. Hmm. All right, there you go. So as you can see, the error is a type error. Okay, you also have to learn how to read error codes. So it says it is a type error, can only concatenate string, not int, to str. So it already sees that the first one is a string, and then the second one is an int. Okay, so can only concatenate string to string. So the second one needs to be a string in order for concatenate to work. So the plus here is used as an addition operator. The plus here is used as a concatenation operator. Now you might be asking, what is concatenation? Now, concatenation is basically just combining two different strings into one. So for example, okay, we have mug and then plus coffee. Okay. Now, as you can see, this is what happens when you add two strings, right? You concatenate the two strings. So you combine them into one. So it says mug coffee right now without a space, okay? You might be asking, sir, can I add a space? Yes, you can add a space here in this string or in this string at the beginning, or you can add an entirely separate string of a space character like this one. And if I run this, it will say mug space coffee. But these things are just a combination. It's just a combination of these three strings. All right. Okay. So data types. Let's see. An analogy of data types would be, let's think of an analogy. Hmm. Um, analogy. Mhm. All right. So let's say you are in a concert, right? So at a concert, there are VIPs, right? And then non-VIPs. So you can actually treat that one as a data type, right? Because only the VIPs have access to the artists at the back of the stage, right? While the non-VIPs can just sit around and wait at the front of the stage. So that's one analogy that I can think of right now. Okay. So what else? What else do we need to discuss? You can try searching online if you want the definition of the functions, right? So there are two ways. You can go directly to the documentation, the official documentation of Python, or you can just search one from anywhere. Okay, like for example, print function Python or something. And then things like W3 schools will pop up. So just click it like that. And then it will show you something like examples, definition and usage, the syntax as you see here, which we'll discuss later, and then the parameter values, okay? But technically the important part is the examples and how to use it. All right. Now we're done with arguments, right? let's go to parameters. So if arguments were more on the value that you are passing, right? Parameters are the things you can edit to change the way the output works. All right. So let's take a look at what we have here. So this is the full syntax of the print statement. Okay. The print function. So this is how you read functions, right? You have to learn how to read the syntax and also how to use the function itself using from the description of their um, functions, right? So, okay, okay. So as you can see, each parameter is separated by a comma, all right? So that's also true. And other parameters, if you observe, have equal signs, okay? Because you are assigning values to those parameters, okay? Um, let's start with object, okay? Now, there's actually a quick description below here. Any object and as many objects as you like will be converted to string before being printed. So it's telling us that the output, right? All the outputs that we got here from the print function, like this one, is already in string format. This here, the 45 is converted into a string format as well. Okay, a string data type. Um, Separator here specifies how to separate the objects. If there's more than one, default is a single space. Okay, so let's try and experiment with that. These two first. So it says objects, right? Any object and as many object as you like. Okay. So we have a lot of terms, right? So when you say object, right? For now, let's think of objects as anything that we can see in Python is an object. Let's think of it like that. Okay, it's actually much easier. All of the um right, all the things that we see. Okay, correct me if I'm wrong. Forgot my example. Okay. Give me a minute. What is wrong with my okay. Um, you can think of everything that you see in Python as objects for now, okay, to make it easier for us. So if it's anything in Python, that means we can put anything as well inside here as our objects, right? But it says any and as many as you like. But lately we've been using only what? One. Okay, there's only one. Okay, this counts as one because on each separate parameter, you have to indicate a comma. Okay, each one is separated by a comma. So let's try this one out. Mm, right. If I were to print like different strings of text, mug, comma. So that's one object, right? Again, treat everything that you see in Python as an object. Okay. And the instruction for the first parameter is as many objects as you like. So meaning after the first comma, I can put another object here like what happened? Um like cell phone or what else? Rock. Um wind, for example. Okay. So as you can see, as many objects as I like. Okay. Now, what would happen to the output if we were to run this, something like this? Okay. Multiple objects, not just one. Okay. Um, if you run this one, it will look something like this. Okay. So there's a space in between and then between each word. Okay. Now, you might be asking, sir, why is there a space in between? Well, even though we did not dictate the space in our arguments, okay? Because of one of the parameters, the separator parameter, okay? Now, from the description of this parameter, it says, specify how to separate the objects. If there's more than one, default is a space, a single space, okay? So again, the separator is used to specify how to separate the object. So basically, the parameter, as you can see, is trying to change the way our output looks. Okay. So currently, we're just using strings for this one. Okay. Um, okay. Object, separator. Okay. So each object, right? Mug, collection, rock, and wind is an object. And each object in between there is a single space. So that's why we have a space here in between. All right. Now, what if you were to change the value of the separator, right? So how will you change it? You have to start with the word sep equal and then the what do you call this one? The value for that parameter. Okay. So in this case, we're gonna change the default value of space. Yeah, let's go. Okay. So I'm just going to copy and paste this one. All right. So again, another comma because we have to separate each parameter by comma. But this is the part where objects end. Okay, this parameter. Because after this, right, if you decide to use the sep parameter, you're going to have to indicate it next as well. So, comma, sep, right? And then it's using the equal sign. Okay. If I were to if I want to change the separator to something else, let's say I want the objects to be separated by colons instead of spaces. So I'm going to put colon here. It should be in string format. That's what it didn't indicate. What's wrong with it? Okay. So it needs to be surrounded by a string. It's not really indicated here, but okay. Okay, here it is. So, open and close, single quotes. So double quotes and single quotes work the same way. Okay. No need to overthink that one. Um, right. So the separator now is a colon. If I were to run this code, as you can see, it will separate. Actually, it's not even separated anymore. It's all combined into one big text. And in between them is a colon, as you can see here. Let me just zoom in a bit. So there is a colon in between each word. So that's the use of the end, the set parameter, right? You can basically change the output of your function using these things. Um, so in this case, this is the parameter, right? Set parameter, but the argument here is colon character. That is the argument. Okay. Um, it just so happens that we were trying to overwrite the set parameter. That's why we can see it here. Okay. So what about the other um parameters that we have here? Okay. So let's just stick to end. We'll stop at end because file and flush is a bit more complicated actually. And it's not really used a lot in my experience. Okay. So end parameter, optional. You can or cannot declare it on your syntax. Okay. So an object with a write method. Oh no, wait, end. Specify what to print at the end. Default is /n. All right. So if I want to change the end parameter, I have to put a comma here and equal, and then it has to be a string data type as indicated here on its instructions. Okay, so end, what should we put? End vacation of vacation. All right. So what do you think this will change? Okay, if the SEP will add something in between the different objects, the end parameter will what to print at the end. But basically it's just you know, whatever you used before, it's gonna disappear because you overwrite it with something here in this code. So if I were to run this code, right, we're gonna see mug, cell phone, rock, wind, wind, wind off, rock, wind. Ah, okay, so it's only up to here supposed to be. The off here is for the okay. Hold on, guys. The coffee's not working anymore. All right. So, okay. So as you can see, the end here, um, instead of going to the next line, right, it stays on the current line and then prints where the cursor left off. Okay. If we were to use the default value of this, which is /n, right? If we were to remove this parameter and go to the optional value, the default value in this case, if I were to, okay, we can't really see it if we don't have another print, okay? Another section, for example. All right. Okay. So as you can see right now, it's two different lines, okay? But if you put here a n parameter of a different value, so we have Let's choose a different character. How about dashes? Dashes. All right. So if I were to run this code, as you can see, from mug up until win, there's some dashes there because this is at the end of your projects, right? It will add this line at the end of your projects. Okay. And then print the next line of code if the next one is also a print statement. Okay. So that's what you see here in this output. Let's see. So again, let's not discuss the file on flush. It's fairly complicated and it's not really used a lot in my case. Um, let's see, what else have I forgot? So we have object, syntax, routers. Mm. Yeah, I think that's all there is. So basically all you have to do is just play around with it and get the hang of using functions. All right. So let's see. Let's have another example. So we're using strings here, right? We can also use numbers because numbers are objects. Again, treat everything that you see in Python as objects. So if you were to print multiple objects for numbers like 1, 2, 3, 4, 5, 6, or something. Okay, so as you can see, it will still display it by default. There is a space because we have a default value for separator. So it says here optional, right? If you did not declare the separator, the default value is um this one. Okay, the space. That is a default value. That is what we also see here, the space in between. All right. Okay. Mhm. All right, so it's time for us to go to our second function, and the second function is called the input. Okay. Um, Basically, this will allow us to give input to our um project. Okay, so input has this kind of oh wait, I have to search for it. Input Python. Okay, so this is the syntax. So it just says input and then prompt. What is the prompt? The prompt it is a string representing a default message before the input. So basically, this is your message to the user, right? Before they give an input. So if we say something like input and then ask a question, what is your name or something, right? And if I were to run that code, it will now show below. Hmm. All right, so when you run this program, it will show on the output what your prompt is here and then ask the user a question. So what is your name? You're gonna type it in here. Like let's type in my name, Daniel, right? But it will not do anything. Why? Because the value is not stored anywhere. So we need to use a variable in order to store the value. So in this case, we can declare immediately what the variable is, what the variable name is. Okay. As for example, this is my first name. Okay. So this is how you declare variables in Python, right? You don't have to declare the data type that it should store. Python will automatically detect that one for us, depending on what our input is. Okay. Um, so if we plug it in, first name here, and then run our program again, okay. So if I type in any name or any value in this case, it will now be stored in our variable. So let's discuss what variables again. So whenever we say variables, you have to think of it like it's a box with a name on it for what things can go inside. Let's say, for example, office supplies. So you have a big box and then office supplies, right? So the only thing that you can put inside that box are those things related to office supplies, right? So since you are kind of like filtering out what can go into the box, right? You're essentially saying what data type you want to be included in the box, right? So in that case, your data type is what office supplies. Okay. So that's what the variables are, okay? And just like boxes, in order for us to remember what is inside that box, right? We don't have to open it anymore. We have those labels we put in boxes, or we just write in them directly, okay? Office supplies. Um, so that's basically what a variable is as well. It can hold on to a certain value for a long time. Okay. Now, since this is stored in the first name, if I were to go to another line here and then say print first name, okay. Again, why am I using a variable as an argument? Okay. Because again, remember the official um, syntax for Python's print statement, print function is um, what you can put in the beginning is any kind of object, right? So the variable is also an object that is holding the value of what is asking from its user, okay, using the input function. So if I run this code, it will obviously say my name at the end or whatever it is I type here. Okay, so as you can see, it's saying Daniel here at the bottom as well. All right. Okay. All right. So integers and a float. Mhm. So in this case, it's using inputs, right? Two input functions to get two numbers. So the first number, right, is 23 and 44 in this example, but the first number is stored to the variable first. The second number is stored is treated as a variable. Oh, no, wait. Yeah. You need to put that data inside of your variable and then you can print it out or show it on the output. So let's have a quick example of that one. Mm, Just reload the page. I think I'll just keep on adding here at the top. It keeps on doing that glitchy thing. It's very annoying. Um, okay. So what, yeah, multiple inputs. So it says first, right? So it's gonna say input, um, give, give your first number. Okay, and then we have the second variable here. Hmm, I forgot the code. Give me a vacation, for example. So now, this program will ask our user two questions, right? And then those questions, our answers to those questions will be saved to the variables first and second. So we can play around them in this time. So if I was to say print, okay, and then first plus second, we can perform operations as well on variables. Um, yeah, give me your first number. Now let's just make it simple. Give me your second number. Okay. So if I were to run this program, it will ask for the first number. So for example, 50. And then on the second one, it will also ask for another number, maybe 70 this time. Okay. And it will come out as 50, 70. Now, can anyone, right, give me an answer why the output is 50, 70? Can anyone volunteer? Just to make sure that you guys are here and listening. Yes, sir, June?
Outputs are concatenated.
Yes, that's very good, sir. So outputs are concatenated. Um, so you have to find a way to convert, right, those strings into numbers, okay? Because right now, Python is reading them as strings. Okay. Now we can go to another function that we have, okay? And it's called the int function. Now the int function is actually very simple as well. It has two parameters, but usually we just use one with it. Um, so int, right? You will pass in a string, a number string. No, wait, a number that is in string format. Okay, and then it will convert it directly to its equivalent integer. Okay, value. So in this case, we can say that we can pass in int, right? Here, right? Int, and then go to second, so that we can get their number equivalent, okay? Because it's currently reading it as strings. Now, after using the int function, it should be reading it as numbers. So if I run this now, so 50, 70, it will now add them like they were actual numbers, okay? Um, So usually my students are confused at this part because, sir, I thought functions are you can put functions inside of functions or as an argument. Yes, you can put a function inside of an argument because again, what was the condition? Treat everything that you see in Python as an object. Even the function can be treated as an object. All right. Um, so why can we treat this one as an object? So it's fairly simple. It's not technically the function itself. It's more like the result of the function. So when you are processing int, right? What comes after this one is, if we have another example here, right? If we just say int of like 50, what will result from this if you run this code is the number 50 itself. You can check if it's actually a number by using the type function, type int of 50. Okay, so actually it will say that it is an integer data type. Okay, you can use this type function if you want to check, okay, what type currently the value that you're working on, what type it is. Um, so basically the result when you use an int, okay, it will give you the result of 50, the number 50. Okay, so that number, okay, that number is the object, not really the function itself. It's looking at the result of the function. Okay, um, that's what it's trying to look at, and the result of the function is a number. The number again is an object, so that's what it's trying to look at. Okay. Hmm. So I think I've demonstrated input and let's see. Okay, so we also have float, but this is for numbers that have decimal places. So if you're working with numbers that have decimal places, do not use int, use float for it. Okay, and let's see. Yeah, we don't need to do this one. So take a look. It's using the int function directly after the input, right? Because Right. What is the return of the input? What will it give us? It will give us a string equivalent of whatever we put there, right? And using that output, we can just pass it directly as an argument to the int function. That's what we get here. Where is it? Here. Okay. That's what we get. Pass it directly to the int function, the result of this part of our code, the input. Okay, so input will input a number. Then it will become a string because of the input function. Then, because of the end function, it will be converted into a number again, which will then be saved to our variables width and height here. And then we can perform some mathematical operations on them. So whether you are using it like this or something like this, where you are using the int outside of the input, um, you can actually do that one. But this is more efficient. Why? Because you're going to be using odds are you're going to be using those numbers that you collected um multiple times, okay? If you keep on using input for each time that you use that number, okay, so you keep on converting it. So it's very inefficient. So you can actually do it like this. Put directly the int in the beginning part and then input inside of it. Okay, and then it will directly be converted into a number equivalent. Just be sure to save it to a variable. Otherwise, okay, um, you won't get to use that value again. Okay. Let's see. Have I forgotten something? Okay. Mhm. Okay, so that's just an output. Mm, yeah, it's the same as what we had earlier with the runtime environment, but this time it's using the PVM machine, syntax checker, and translator. It's basically the same thing, but this is more specific to Python. Syntax errors, yeah, we've had examples of this one. So you have to learn how to read errors. From my experience, reading errors from Visual Studio is actually much harder because there's a lot of extra information being presented to us there, whereas errors in uh, IDEs like Jupyter Notebook is uh very concise. Okay. So it's um just a few lines, okay, and it actually specifies more readily what kind of error you have. From my experience, really, when using Visual Studio compared to Jupyter Notebook. So each one has their own advantage and disadvantages. Mm, indentations, yeah, we'll get to that later when we get to it. Currently, we're not using any indentations right now. All right, so we're finally at let's see, we're finally at the ending part. Okay, so let's summarize everything that we have learned so far. Uh-huh. Nope. So this note is actually very confusing because I've been going up and down basically because of this thing. I don't know what's happening with this. Uh, Maybe it's because it's not maximized. I'm not really sure. Okay, so now it's not even showing properly. All right. So let's summarize what we have learned so far. Um, we have learned the print function, right? Um, yeah, we have learned the print function. We have learned the input function. What else? We have learned the int function, the float function. So int and float, the way that you use them is basically the same. Just use the float for numbers with decimal numbers. Yeah, decimal points, and then integers for integers. Okay. Including the negative values. What else? Print input. I think we have something here before. Yeah, string concatenation. Yes. Let's see. What else? We've also learned what data types are. Okay. So currently we only had two. So numbers and strings, right? So strings can be further broken down into its smallest value possible, which is a character. Okay. What else did we learn? It's better to treat everything in Python as objects. All right. So it actually makes your life easier if you think about it like that. Because technically, okay, in Python can be treated as objects, so if you pass anything to the print statement, it will always give you a certain output. Okay, so that's what I'm trying to say. Because it can see those things as objects. Okay, when the print statement gives you an output, that is an object. Okay, which is almost everything really. Um, what else? So we also learned string concatenation. Concatenation. Mm, let's not go to the history and those kind of stuff. Let's focus on Python. What else? We also learned arguments. We also learned what functions are. We also learned what parameters are. Right. What else did we learn? Mm, We also learn syntax, right, and how to read it. Um, References. Those are the references. If you want to see, right, if you want to take a look at what the print function, okay, how difficult it is to read it from the actual documentation. You're gonna have to go to python.org, okay, and then go to documentation, Python docs, all right, and then yeah, we're using the latest one. So you can search by version. Sometimes different functions have different ways of using them depending on the version that you have, okay, that you have. So there's a tutorial here as well if you want. But yeah, I think let's just do a quick search. Okay, print. So I have a history here already. Okay, so if you search for print, it will look for that specific keyword. Okay, but what you're looking for is the print function. So you're gonna have to read each one. So Python module in p print data pretty printer. Not really what we're looking for. How about this one? Python function in built-in functions. So I think it's this one. Okay, so click on it. It should be somewhere above. Here we go. Okay, so take a look side by side. This is the syntax shown in this website. This is the syntax shown from um, the official documentation for Python. Okay, so if you were to ask me which is more complete, this is more complete in terms of definition. This is more complete because it has examples and an easier way, an easier description on how each parameter works. Okay, but if you learn how to read these kinds of things, it will actually help you a lot in the end because for something like this, for example, say objects with an S capital, okay, it's actually represented in a different way by developers. They use a asterisk symbol at the beginning to indicate that you can have more than one, all right? More than one, even though there's an S here. So that's one thing. Another thing is they put directly the default values on the parameters themselves. Okay, in this case, they separate it like this one. Um, but here they put it directly to the parameter in the syntax. It's in the syntax. So if you read description, prints objects to the text string file separated by the sep and followed by the end sep end file. Okay, followed by the end. Sep and file and flush, if present, must be given as keyword argument. So this is actually not indicated here, all right? It's assuming that you already know how, but here it's explicitly indicated that it must be given as keyword arguments, okay? So what are keyword arguments? This is what we were doing earlier, okay? You were specifying them by name. Okay, you are specifying them by name. Like for example, print, and then you have one object here, right? Mug, and then you are specifying the sep parameter. That is the keyword, right? So it has a that is a keyword argument. You are specifying directly the name of the parameter. Okay. Oh, by the way, you're curious if what happens if you swap them out, right? So if you swap them out, it doesn't really matter for keyword arguments. The only one that are keyword arguments here are indicated as follows: sep and file and flush. It did not include objects, okay? So only these four are keyword arguments. You can determine if it's a keyword argument because of the equals that you see here, okay? Right. So that's your determine what are keyword arguments. And since they are keyword arguments, okay, you are referring to them by name. That means it doesn't really matter if you um swap them out in their sequence. Okay, let's say for example, we'll start with step and then oh no wait. separate. So let's swap them out. So this is end. Okay. Let's delete this one. And then sep is here. Um, what asterisk. And then let's have another print statement at the bottom, just so that we can see the effect of sep. Um, another, another. Okay. So as you can see here, even though we swap them out, we can still have the same result, even if we did not follow the correct. So if we swap them out again, like this, following the correct sequence. Okay, just to show you guys that it will have the same output. Take a look, mug and another, they have the same output, okay? Because Python can understand that we are actually referring to these two things, all right, by their names, not their positions, okay? This one here, objects, is not a keyword argument. So what do we call this one? We call these positional arguments by position. So if you encounter things that are not keyword arguments, they must be followed in the same order. Okay, so that's another thing that we have learned. Arguments. So we have positional arguments and then keyword arguments. References. Okay. What else? Hmm. But to be honest, this is actually very hard to read. If it's your first time, it's actually much easier if you start here. Things like resources like this one when you're trying to read, okay? Because what are we trying to do, okay? As data scientists. So odds are you're not going to be making your own functions. Okay. Um, yes, you're going to be making them, but not a lot. Okay, because what will happen is we're going to be using that functions that are already made by others. So all we have to do then is just to learn how to use the function. Okay, because that's what we have been using, right? Um, it's a concept called um, abstraction, right? Where you don't need to know what happens underneath in order to use it, right? Like, if you remember, the definition of function is what? It is a pack of code that does something specific, right? But we don't actually know what's inside of it, right? We can't see it unless we made it ourselves. So, if we have to make an analogy, right? Think of a car. Um, you only need to know how to use the wheel, the brakes, the accelerator, the clutch, if you have a clutch, the gear, and that's it basically. And you can some basic maintenance, and then you can drive the car, right? You don't need to know how the engine works. You don't need to know how the air conditioner works, how the shaft works, how the differential works, how the fuel injection works, right? You don't need to know all of those things in order to use the car. That is abstraction. That is the purpose of the function, right? So there are a lot of functions that we're going to learn from then on. And what I'm trying to teach you here is how to read a function, right? The syntax and how to use it so that you can read new functions by yourself and explore further. Okay? Because if we are gonna discuss all the functions, like I think it's here, if we are going to discussion all the functions available in Python, then 10 sessions won't be enough. So I am equipping you the skill to read it so that you can do it by yourself. All right. And with that, since we're almost done, okay. So annoying. Okay. Let's have a quick exercise. Exercise. I'll make this one to mark down. Okay. I want you to calculate the area of the rectangle and then exercise 2, calculate the average of three numbers. So these are the um exercises that I want you to do. All right. So, if possible, I want you to make use of all the functions that we have learned so far. So, for example, here, you need to um, prompt the user for the um, length and width. All right. And then in this case, prompt the user for the length. Why am I having wrong spellings here? For the three numbers. Okay. So you can use an input in this case in the beginning, and then I want you to make use of. So that's something that I forgot to put here. We also learned variables. Okay. So put them into variables and then uh calculate the answer and then provide them as an output later. In the end. Okay, maybe you can print them out. The same thing goes for the average of three numbers. So get the three numbers using input, and then um, it's up to you if you want to use integers or float, as long as you can get the average. Okay, and then print them out in the end. Okay. All right. So I think I can zoom this one here. Okay. So I think how many minutes? 15 minutes or 20 minutes. So there are two questions, 10 minutes each. Um but if you guys finish early, then I think 15 minutes is enough. Maybe even less. Oh, what's happening? This one. Okay. Ah, okay. Okay, this one works. All right. So, yeah, 15 to 20 minutes and then we'll check your work. Okay, I'll ask two of you to present your answers and discuss it with your classmates to the class. And that's it. Okay. So let's just use this one as our break as well. So if you finish early, you can take a break and then let's get back at 4. Let's meet back at 4. Okay. Be sure that you have your answers by then. All right. So yeah, happy answering. Oh, there's a chat. It's treated as streak. Oh yeah, I'm sorry, sir. I just saw your message now. It's on the other screen. All right. Okay. So answer the exercise and then let's meet back here by 4. I'm sorry, I was on mute. Okay, I see your message, Sir Albert. Don't worry, we'll take a look at your solution. All right. Um, okay. Who wants to go first? Who has an answer? Let's answer first the exercise and then go to the concerns of each one. Who wants to answer number one?
Me, sir.
All right.
Can the should I message the solution, sir?
No, sir. You can share your screen. Let me stop my
Uh,
share.
I'll
All
just
right.
share my notepad. Because I'm running some issues with my Anaconda Jupiter.
All right. Can you send me your code and then we'll try it out.
Sure. I just messaged sir the code solution for the problem.
All right. Okay. So let's try out Sir Ryan's answer. Mhm. Okay. So I can't seem to copy. Yeah, Zoom actually doesn't allow us to copy and paste.
Mhm.
So as you can see, I can't copy and paste your code. Can you send it as a file, a text file?
Copy, sir. Sir. Uh, okay, sir. I've already sent the text file for the solution for the problem one.
All right, I see it. Okay. All right. So can you? Yeah, you can see my screen, right, sir? Okay. Can you give us a quick explanation on what you did here?
Sir, first I declare these variables, the length and the width. I use the float data type because even though the users input a decimal, it will be considered as still a number. So then, after I declare those variables, I create this so it's called operation. I multiply the length by the width and The result of the computation will be stored in this variable area. Then I will print the result on this um, uh, print message. I put this curly uh, the area with the curly brace because I'm familiar with Django Jinja, so this is my practice.
Right. So thank you for that, sir. Let's try it out. So if I run this program, let's see, 5 and then 4, 20. All right, that's correct. If I were to say 5.5 times 4, correct. Okay. So if the user just inputs the correct values, right, it will work. Okay, because that's what we're trying to do. But in reality, things like this, there's actually um more code, even though it's a simple calculation, there's actually a lot more code included because we have to expect that the user will sometimes input wrong data, right? So we have to find a way to or have a workaround around that. But this is already good. This is correct.
Mhm.
Activity. All right. So I see your output here, Sir June. All right. I'll have you next. Okay. I forgot actually this one to teach you earlier. So what Sir Ryan is using here is called a comment. All right. So it starts with an asterisk. It starts with a pound sign, and whatever comes after that is commented out, meaning it's not executed by Python. So whenever Python encounters that line starting with a pound, it will essentially skip that part. So what is it essentially used for? So it's very useful with you um, if you want to communicate to other developers what you're thinking, okay, at that point in your program. So other developers can understand the flow of your program, okay? Another use of that is to um, temporarily disable lines of code. So when you're testing out, you're troubleshooting your programs, right? You want to disable some lines and then enable others. You can use comments to do that one. Instead of deleting the line itself, you can just use comments and then um, effectively skip that line of code. So in development, right? In any kind of development environment, whether you're in game dev or web dev like me, um, it's essential that you actually know how to comment as well, right? You know how it's more actually it's more communication. There's more communication than programming, in reality. So you to effectively communicate your idea, right, is a much sought after skill. It's what other developers are also looking for, instead of you being a 10x developer or like a genius level, okay, or something like that. Because what's the use with working with someone that you can understand, right? So you have to be able to bring your idea out effectively. So there are only a few really good developers that can also actually effectively communicate their ideas well. Also. So yeah, that is a good skill to have to explain, to comment out your code. It doesn't really have to be per line of code, more like the general thought that you had at that part of your code. Okay, more like just you can separate your code into different sections, something like that. That's what I usually do as well. Because if you have too many comments, right, then there's too many things to read, and what happens is that the idea that you want to uh, give, right, to the other developers is gone. Okay. What else? Sir Ryan is also using something called an F string, so we haven't actually gotten to this topic yet, so we'll get there when we discuss um string formatting. Okay, we're gonna format the way our output works is displayed. So don't get confused with this yet. If you guys are watching this recording, we'll get to that later. Okay, but basically, um this entire string here, right? If there's an F in the beginning, that is an F string. And if you want to put a expression inside of your string, directly inside of your string, you can use a open and close curly brace and then put in whatever expression you want inside. In this case, it's not an expression, it's just a variable. That's why when it is printed out, it will display the value of that variable instead, directly as part of the string. So it's kind of like a shortcut, sort of, um, instead of you doing it like this. So the equivalent of this is if you were to do something like the area of the rectangle is, and then space, and then, oh no, no, wait, there's no need for a space because there's a separator, right? Or we can put a space and then just use a concatenate. Yeah, something like this. Area. No, no, wait. Area has to be converted into a string first before you can concatenate this one. So you're going to have to use an additional function. So just like with int, we also have something that converts a number to a string. So it's called str. And you're going to have to pass area here, and then plus, and then space square units. Yeah, this should work if you're using concatenation. If you're using um as objects, right? You can do it like this. 9. Uh, if you're using objects, you can do it like this. So no need for a space there. You can just use directly comma and then area and then comma and then square units without the space because it's gonna generate a space because of the separator parameter. And this will also work as well. So all these three have the same outputs. Actually, let's try it out. Let's remove the, okay. Let's say I have 5, 4. Okay, so as you can see, it has the same outputs for all three of those types. Okay, so one is using the F string, this one is using the string concatenation, the third one is using the objects parameter, okay, where you have to separate it into different objects. In this case, you're not using an extra function, you're just using it as is because it's going to be converted into a string either way. All right, so good job, Sir Ryan. Next is, let's download Sir June's output. Right. Okay, Sir June, can you give us a quick run through with your program here?
Hmm. Yes, sir. Good afternoon. Uh, the approach is somehow similar to the first activity. We just need to assign three variables to accept the values of first, second, and third number. And then we assign the average variable to compute by adding the values of first, second, and third inputs and then dividing them into three to get the average and then print the output by by concatenating the message and the average variable declared as string.
All right. So we can add this one as one of the things that we have learned, right? The string function. All right. So good job with this, sir. If we were to run this code, first number is 5, 10, and 15, right? It should be 10. Yeah. All right. Let's see. Okay, good to go. So good job on this, Sir June. I think there's nothing more to add to this. So good job. Let's see. So Sir Albert, yeah, you've been having errors since the calculation of dimension. Can you give us more context on what's happening with your code, sir? If you can, maybe you can share it if it's all right. Share your screen.
Hi. Yes, good afternoon. Yeah, I replicated this formula. I replicated, but doesn't want to prompt the screen to well. I've been having error of this. I'm sorry. Okay. All right. Now here it is. Here is the error, and we try coming out when I play this. It's a shall not executed.
All right. So let me take a look. Okay.
Uh,
So
I I tried theirs, but even we tried. I also checked with the editor. It was working, but why?
mm,
And the editor on the Python editor, and it was running okay on the first two lines, but this one when I checked, it's a error. It prompts.
all right. So the reason there's an error, sir, is because it's reading each line as a code, right?
Right.
All right. So what you have on line 3 and line 4, those are not part of the code, right?
Yeah. So
Yeah,
close the
so
query.
try commenting them out and then running the code. Cell not executed.
Yeah.
Can I see the error again, sir?
Ah. Yeah.
Okay, cell not due to pending input. Submit your all right. Okay, can you press OK, sir? All right. So it seems that you have run a program earlier that did not finish. So I want you to go to kernel, right? So if you've noticed the circle on the top right, it's black.
Yeah.
Do you see it? Okay, so
Yeah.
whenever that's black, it means that something is using your kernel currently. So you can't, that's why you can't run your program. So what you
Okay.
need to do is restart it. Restart kernel. All right. So wait for it to turn white. All right. And then run the
Ah.
program. Okay, now try running the program. All right.
Oh,
There
there
you
it
go.
is. Okay. Now we can now I can we can run it already.
All right.
Okay. Now I can perfect. Now to the now I'll just fix this. So kernel and then we
Yeah.
stop.
So whenever you see the black thing that's not turning white, okay, it's been black for quite a while and you did not do anything, you can just restart the kernel and then wait for it to finish. Okay.
Okay.
So that goes for everyone as well, who's listening to this recording. When you have that kind of error, just restart your kernel. All right. So any other questions, sir?
No, just I just have to just have to what's this? Just redo the exercise because there's something the setup. Found the troubleshooting error is I don't know all the basic function yet for this one. Even the reset, I don't even know what that is yet. No,
Yeah,
no. Yes.
yeah. That's okay, sir. That's all right. Okay. So how about the others? So were you guys able to get the same answer as well, the same solution, or somewhat the same solution? Or any other questions that you have that you might have, clarifications with the discussion? Sir Kier, Sir Ed Ryan, and Sir Alex. How about you guys?
I'm good. I don't have any clarification so far.
All right. So Sir Kier is good. Sir Alex, how about you, Sir Ed Ryan?
Um, can I share my screen, sir?
Yes, sir.
Thank you, sir. I'm sorry, sir. I have no Anaconda installed. Let's
That's okay.
let me just use the online um compilation. So this is my work for the first exercise. So as you can see, I converted the input into an integer for the length and width, and
Mm,
as simple as the print, the inputted integer was reflected.
okay.
So for the computation, it's just length times width.
All right. Very good, sir. So it's a different kind of
Where
way of doing it. All right. So you got all the basics done. Can you go back, sir? Can you try removing the open and close parentheses for the length times width? I think it will still work if the open and close
oh,
parentheses is not there because you have a comma as a separator. Try it out.
okay, so I think it's gonna be all right.
Yeah. All right. So
Simple.
so it's not really an error. It's more like cleaning up your code. So less characters, less things that bothers your eyes when you're reading it, especially if others are reading your code. So it's less confusing. If they read that one, they might be confused as to why you put a open and close parenthesis there. They might thought that is this a function? Is this a something else? Because you place it in a different um open and close parentheses. So yeah, it's not really an error, more like it's an improvement. So good job, sir. How about the other one?
For the next exercise, sir, just like the other answer,
Hmm.
I just made three entries for the numbers. So I use function round to make it into a two decimal um
Your
number, sir.
decimal out. All right. So did you search that one yourself, sir? The
No,
function?
I've been using this for,
Ah, all right.
so I know already the functions.
All right. So what sir is using here, Sir Edward is using is the round function. The round function basically has two parameters. So first is the number itself. The second is how many decimal numbers you want to produce as an output. So in this case, two. So two decimal places. So from the output below, you can see that it's just two decimal places, 9.67. All right. Okay, so good job with this, sir. Um, let's see. So there's nothing else for me to improve here. Yeah, I think that's good. All right, thank you, sir, for sharing your answer.
Sure.
So Sir Ed Ryan actually has a very compact way of presenting his answer. So that's good as well, right? So either way of doing it, like um, it's actually as for Edran's solution is much more efficient because you did not declare an extra variable. So if you're declaring an extra variable, it's an extra process, so it takes a little bit more time. Um, but with our devices, in these modern times, it's actually quite fast, so we don't really see the difference. But if you were back in the 80s and 90s, um, the difference between a line of code is actually very big because it can take quite a while to finish. That's how slow the computers were back then. Um, what else? So if there's a rule, no, not really a rule, more like um, for beginners, try to focus on making your program work. Don't focus on efficiency yet. Don't try and make it to be as few lines of code as possible. Try to make it so that others can understand your way of thinking first. I think that's more important really than making it more efficient because in the end you can just do that one carefully, right? When everything is done, when everything is working, you can just do that one carefully and make the code um lesser lines of codes and more efficient. So we call that one refactoring. In web development, we call them refactoring the code. I think it's the same with the um other environments as well. I think they have the same exact term. All right, so that's just an additional info for you guys. Right, so now it's, let's see, 4:30. All right. I think it's all right for us to proceed with the next PowerPoint. Okay. So it's always right if we don't use the time that we have. We still have a lot of things to discuss actually. All right, so let's go to control structures. Mhm. Right. Okay. All right. So, control structures from the name itself is the part in our program where we can control the flow of where Python should go next, right? Um, so there are a lot of ways that we can do this. We have the if, we have the loops, right? In this case, it's the for loop. That's what we're gonna discuss now. And yeah, there's the while loop. There are, let's see what other statements we can use. But yeah, there are ways for us to control how and where Python should read next, what line to read next, depending on what we're going to use. But we're going to start with the for loop, okay? Now, from the name itself, loop, when you hear the word loop, you think of a circle, right? Like, it keeps on going back to the beginning, and that's the same here in the for loop. The difference is that um the for loop has a definite ending. Okay, so you can indicate how many times it will repeat, right? So that means it has a definite iteration, as you can see here. Um, so we have a different loop for indefinite iteration. It's called the while loop, which we'll discuss later on. Okay. Now, each repetition of action or each repetition of a certain set of code is known as a pass or an iteration. Okay. And yeah, I think that's it. So again, loops allows us to repeatedly execute a block of code as long as a certain condition is met for a specific number of iterations. Okay. Let's say, suppose that, for example, you're working for an e-commerce company, right? And then you have like a database. So you're gonna have a database of customer orders. You're gonna have a list of those things. You can access that in your dashboard, right? So what if you were tasked to validate the data and ensure its accuracy, for example? Let's say you are a VA and then you're gonna download a VA as a data scientist, right? Um, they ask you to download the data that they have and then, do some data analysis stuff, like maybe import it into Power BI, for example. So, um, let's say that one of the steps that you're gonna do is you're gonna check the order total, right? If it's within a reasonable range, like you're segregating the total amounts by ranges, and then um check which orders are valid. So you're gonna filter them out, for example. Um, you can, what else? Mm, check the shipping costs that you had, right? Where are your customers usually coming from? Are they coming from a certain country or a certain area of your country or something like that, right? And how many of them have canceled? So those kinds of data, right? It's available in your dashboard. I don't know if current e-commerce have those kinds of things already. I think they have a basic look, but they don't have the advanced versions, right? So if you want um, an advanced data analysis of all your orders, you're gonna have to get that data, right? And then perform those steps. Okay, so let's just start with the one of the steps, like checking if the order is valid. Okay, so what are you gonna do? You're gonna um, take a look at each order and verify that the shipping address is valid, right? Or where is it going for? Okay. Um, and let's say there are over 10,000 orders in your account. Okay, so don't tell me that as a person, you're gonna have to take a look at each of those orders and verify each one. All right. So before we usually do that, okay, before computer, right? Um, I think in accounting, there's something called the double entry method. So they use that one to double check everything. But nowadays, we just use computers for this and specifically data analysis tools. Um, so in Python, right, we can use loops for that one. Okay. So all we have to do is pass the data, right? 10,000 data in this case, and then loop over each data. And then we're just gonna have a few lines of code that will check if the address is valid, and then later on we can identify which one is the most common, right? So something like that. So those steps, right, you can just use a for loop or any kind of loop um, to process the data, okay, until it's done. So let's take a look at what a for loop looks like. Okay, so it's a bit confusing, but this is the um syntax for a for loop. So you start with for, followed by a variable. This is a temporary variable, followed by the keyword in, and then finally your um iterable. We call it an iterable. Okay, the first line of code is something called loop header. This is the loop header. Okay, and then the rest of the body is called the loop body. Now, what I want you to observe is that on the loop body statements I to N, there is an indentation here, right? So indentations are important when you want to um, indentations are important. Mm, okay, 19. All right. So indentations are important because they signify grouping of different code, right? Let's say for example, this for loop, right? So let's take for loop as an example for grouping. Okay. Um, so let's start with the keyword for. Next is a what? A temporary variable. All right. So you don't need to assign anything to it. It's just going to be used for this specific for loop variable. Okay. For loop. So let's say I'm going to call this one temp, right? Followed by the keyword in. Okay. This is the exact syntax. And then followed by what? The iterable. All right. And then last but not the least, it's a colon. So this is the exact format, the syntax of the for loop. Then if I press enter in Jupyter Notebook, right, it will automatically take a look, add a indentation for us. Okay. So Jupyter Notebook, Python already knows that the next line belongs to the for loop, right? That's what the indentation means. The next line belongs to the for loop, all right? Now, as you can see, if I keep on pressing enter and typing out, it's gonna be indented, right? So all of these codes, line of codes, belong to the for loop, all right? Now, if I press enter twice, so for example, enter, and then I press enter again, it will go back to the beginning, all right? Now I am outside of the for loop, okay? So any code here is independent of the for loop, okay? Only these things, only these lines of code belong to the for loop, okay? So as you can see, the alignment here, right? So if they're aligned here, okay, um, like they are on the same level, okay, that kind, the same nesting level. Now, if I have another for loop here, for example, okay, so even though they are on the same level, these lines of code here and these things here, even though they are on the same level of indentation, it doesn't mean that they belong in the same group. So these lines of code belong to this for loop, and then these lines of code belong to this for loop, right? Even though they have the same nesting level, right? We call it the nesting level. Um, they don't belong to the same group. Okay. All right. The temp variable here is different to the temp variable here. Okay. You can you can keep on reusing the same variable. It really doesn't matter. All right. So next thing that we need to discuss is an iterable. So what is an iterable? So basically, an iterable is a sequence, right? A sequence of what? A sequence of anything. Okay. So that's what I usually say. So a turbo, okay, is a sequence of anything as long as it is a sequence, right? So what sequences do we know? We know that a string, right, is a sequence of characters. We defined this one earlier, right? So the smallest value inside of a string is a character, right? And if you put them side by side, all the characters, you get a string of characters. So basically, it is just a sequence of characters that you need to follow in the exact order to produce that string, right? It needs to be in that same order for that value to be created, right? Um, Like for example, if you have a string like ABC, right? It's not the same as BCA, right? They are two different strings, even though they have same characters, okay? It needs to be in the same format, ABC, ABC. If you assign them into different variables, then they have the same values, but they are assigned to different variables. That can also be it. All right. Okay, now that we know that a string is a sequence of characters, we can put that here. All right. So we can either do it directly or we can do it via um, variable. Okay, so you can say it like iterable, right? Iterable is equals to a string. So my string here is um, latte, for example, because that's what I'm drinking right now. All right. And then how do I turn off Grammarly? Remove. No, I don't want to remove it. I can't turn it off. Maybe here. Okay. For the session, right? So for temp in iterable, right? And then what will I do with that? Okay, so remember the definition for the for loop. It loops over, right? Every value that the iterable has. So in this case, it will access each individual character. Okay. So if it's going to access each individual character, where is it going to store it? So it's going to store it in our variable here, in our temp variable. So in other words, if we were to print this one out, print temp, what we will actually see is each letter printed out like this. Okay. So as you can see, right, we are looping over the iterable for each of its character. Okay. Now, remember, the iterable is what? A sequence of anything. So anything that it is a sequence, right? Which will have more later, right? There are a lot of different sequences in Python um, that we can use, right? But what you need to remember is that um, it will access it one by one until uh, it's done, until all the values are processed, right? So in this case, until letter E, until that's done. So after letter E, it's gonna stop, okay? So how do I know it's gonna stop? So for example, if I print here, print, and then the word stop. Okay, so take a look. LATTE, stop. So it has to finish the iterable first, this entire for loop, before it um before it prints the next line. Okay, so if you were to imagine, right, an arrow, it will rotate here 5 times. 1, 2, 3, 4, 5. Why? Because we have 5 characters in our string. Before printing out the next line of code here, before going to the next line of code and then printing the word stop. All right. What else? It's not really necessary for us to use the temp, right? Like it's there if we want to use it, but it's not really required for us to use it. Like if I want to print like hello 5 times here, yep, we can do that one. Okay. Even though there's a temp there, it's not really required for us to use it, but it's there if we want to. Okay. Um, we can count it out. For example, like we're gonna have a count variable here. It's gonna start at 0, right? So I want to print out uh, the value of count plus 1. No, wait. I want to print out the value of count at the beginning. It's currently 0, right? So the first time that it loops, it's gonna count it with an additional 1, so plus 1, since this is the first loop. All right, so if I were to run this code, it will say 1, 2, 3, 4, 5. So it just shows that it repeated 5 times. Okay, so just another proof for you guys. If I were to remove the indentation here of the print count, what do you think will the output be? If that is my code, what do you think will the output be? Anyone?
Will print 1.
1. Okay, so Sir June said 1. What about the others? Another one. I need another one to compare with. Anyone? Okay, I'm gonna call out some person. Ed Ryan, how about you, sir?
I think it's gonna be 5, the last iteration.
All right. So we have two answers, 1 and 5. Let's see the correct answer. I'm gonna remove the print stop so that we only see 1. And the correct answer is 5. So Sir Ed Ryan is correct. So it's not actually 1, Sir June. It's because, remember, this is outside of the for loop, right? So it has to finish this entire loop first. Okay, remember it's the iterable is latte. So there are 5 characters, so it will repeat 5 times. So it will add 1 to count the count variable 5 times as well. So by the end of this loop, count will be equal to 5. So that's why the answer here is 5. Okay. So yeah, good job, Sir Ed Ryan. Um, okay, let's see. What next? So that is for the for loop. In this case, it's using range. Yeah, we can discuss the range function. The range function is useful for a lot of things, really. Let's see. Right. So let's just print this one in temp first for now. Okay. Mm, So the range function has its syntax has 3 parameters. All right. So it starts with start, stop, and then step. All right. So those are the 3 parameters. The start is optional. The step is optional as well. The default value of start is 0. The default value of step is 1. All right. So the stop is the only one that's required. So this is required, the second parameter. These things are all positional arguments. So you need to declare them in sequence. All right. So if you only declare one number, that will automatically be the stop parameter. If you declare 2 numbers, that will automatically be the start and the stop. If you declare 3, then it will be the start, stop, and step. So let's start with one number, okay? So if I have a range of 10, right? Okay, and then I'm going to print this out, Control Enter. It will print out the numbers 0 to 9, okay? Let's analyze this one first. The default value of start is 0, so that's why it will start at 0. The stop value is 10, so it will stop at 10 but not including 10. All right. Next is the step is 1, so step of 1. So in each loop, on each call of the function, right, it will add 1 to it. So that's why we see 1, 2, 3, 4, 5. There's an increment of 1. So that's how the range function works, okay? Now, this is a function, but it works like a sequence. So when you read the definition of the range function, right? Take a look. The range function returns a sequence of numbers. The keyword here is sequence. And then what were we discussing earlier? An iterable is a sequence of anything as long as it is a sequence. So meaning you can put it here after the in to loop over with. Okay. So as long as that keyword comes up, automatically you can use it in a for loop that you can iterate over with. Okay, you can take a look at each values one by one, right? So that's the trick. Um, Usually they use some clever words that makes it confusing. Actually, the correct definition is more confusing. What I'm teaching is basically my, um, my understanding of it, like a shorter version of it. So, so that's for range, right? So you might be thinking, sir, why did they not include 10? So the main purpose here is that when you say range of 10, what they want you to think of is that there will be 10 numbers. So if you think about there are actually 10 numbers, 0 to 9. There are 10 numbers. So the range function here is more like when there's only one number, it's more like it's used to um have this kind of thought like I want I want to repeat a certain code 10 times, okay? Like I want to say hello 10 times. So it's very easy, right? So all you just need to do is range of 10. Okay. The variable doesn't matter anymore, actually, whatever you put there. So let's say um, I want to, let's say, I want to add, I want to multiply by 2 the number of count 5 times. So for example, right? And then I have a value here of count is equals to 6 or 4 for this case, right? And then I want to multiply it by 2, 2. Okay. And then finally I will print it out at the end. Okay. So I want to multiply the value of 4 5 times. It's 2. So the answer is 128 or something like that. So range is actually great if you just want a quick um I want to repeat this that many times kind of mindset, right? Um if you want to modify the output a little bit, like I want a range of numbers um starting from 5 up until 100. Okay, so we can do that one. But if it's in steps of 1, there's going to be a lot, right? Let's say I want it to be in steps of 10. So comma and then 10. So what I'll see is 5, 15, up until 95, right? In this case, you have a specific use for each number, right? Earlier, when you were just using the stop, I didn't really care what that number was, okay? But you can use it if you want, right? Again, it depends on your application. Okay, so that is how the start, stop, and step parameters work for the range function. All right, so I think we can end it there. It's already 4:58. We'll just continue this one. Slide 6 next week. And yeah, I don't think I'll leave you guys with an assignment for now. I think everybody got the lesson correctly. Okay, any clarifications before we end our session or questions? All right, none. So if you guys have no question, then we can end it now. And for the video, I'll be uploading it in YouTube. So I think Marielle will just send you guys the link if it's done. For the lecture notes, this one, the one that I'm using here, I will upload it again to the LMS, and then you can just open it in whatever IDE you want. But if you have Anaconda, you just need to look for it here. So just go to File and then look for where you downloaded it. If you put it on a desktop, then you can just see it directly when you click on desktop, right? You can see the file that you downloaded there, or usually it's in the downloads. Then just double click on it, and then you can see my lecture notes, right? And that's it. Okay. Goodbye, everyone. Thank you for participating.
Thank you, sir.
Thank you very
You're
much.
Thank you,
welcome.
sir.